Gilles is joining us from the UK. I guess you're still confined there.
Yes.
You're the last speaker. It's been a pleasure actually, because this kind of Zoom meetings do actually allow us to convene with a large community of people that we know and with whom we usually collaborate, but which we could never bring together in this short amount of time on this kind of different topics. So I'm very happy also that you could make it. It's in your busy schedule. And as an introduction, Gilles, I haven't explained it to the other people following the conferences actually, but I'm just a teacher at Versailles organizing a workshop for my students. And since I thought it would be interesting for them to have some extra information, I invited some people that we know. And then I thought, since we're academia, actually knowledge should be freely available for everybody. So I just sent out the invite to everybody, and we had quite some interesting talks. I hope for my students it's interesting. I hope for the people that joined it's also interesting, of course. There's always a little bit of debate, and that was a little bit complicated that in a regular lecture you have more time to discuss it afterwards and to discuss some points, which I find a bit complicated now, but okay. And then Gilles is one of these shooting stars in digital fabrication too. He's a trained architect and a lecturer or senior lecturer at the Bartlett, and also a researcher. And in his position as a member of staff at the Bartlett, he has been able to come up with quite some interesting thoughts on how to digitally fabricate, how to introduce the digital thinking into our new designs, let's say, and not in the regular sign language that we have with the blobs, but in a totally different way. And I think this is very interesting to close off our week with some views on the future. What could digital also mean? Not only just the regular blobby stuff with a lot of robots and the robots that are going to make all the world. Maybe they are, but maybe in a different way also. And I think there, I'm quite happy to have some critical insights from your side, Gilles.
Okay, I guess this is working. So first of all, thank you so much, Klaas and everyone at Versailles for the invitation. I agree with what Klaas was saying, that it's one of the somehow good things in this very difficult time is that we can all come together and that we can invite lots of people who would otherwise have been unavailable to discuss and to debate and to share knowledge. And I've really seen in the recent few weeks an incredible acceleration somehow of discourse, with tons and tons of lectures being organized all over the world, with people from all over the world participating. So I think that is one of the somehow interesting side effects of this terrible period that we're going through. So I'm very excited to be able to share some of my work with you. I've titled the lecture today, Building, Building. 2 times building, 1 time as a verb, the act of building, and then 1 time as the object of building, the building itself. And I'm going to talk roughly about my kind of 3 hats that I'm wearing. So I'm a lecturer and a researcher at the Bartlett School of Architecture. I also direct the Masters of Architecture program at the BPro at the Bartlett, which is a post-professional masters with more than 200 students who are joining us for 1 year of really intensive research. Then as a kind of a spin-off of my research at the Bartlett, I run a design tech consultancy, which is trying to bring the knowledge that we develop in academia into the real world and trying to kind of find also a new model for what an architectural practice could be. And then my last hat, which will actually probably be, most of the lecture will be about that, is my architectural practice and kind of like endeavors with me trying to also bring some new ideas about building to the real world. Yeah. So briefly, I started my practice from a kind of very avant-garde point of view. I was just really experimenting and trying to develop an agenda and a position that would contribute something differently or would offer another angle of thinking about digital technologies, about robotics, but also about space and aesthetics. So I was working for since about 6 years. I think it's about 6 years ago that I started to practice. And slowly, while developing that agenda, the goal was to kind of bring that closer and closer to the real world and move that into a practice that would not only speculate about building and buildings, but would actually begin to build as well. So these are some of the kind of recent endeavors of that work that is becoming, I think, more and more ready and desires to be built. And I truly believe that architects are generalists. I think the best architects are absolutely generalists. I think as a researcher, you cannot focus on a single topic because architecture is synthetic. It's bringing together, discourse, ideas about space, aesthetics, but also ideas about technologies, ideas about history. So I also wrote these 2 books, which you should absolutely check out after the lecture. If it was of interest to you, one Robotic Building and the other one Discrete. The book on the right was last week in the top 100 of best-selling architecture books on Amazon. So we want to keep it there. So please reach out to Amazon. The work, so the work on the one hand, you have this kind of, my practice, right, which kind of produces these books and these buildings and these visions and positions, but at the same time, also we're really kind of hands-on working with programming robots to build crazy things and to try to kind of bring that into the world. So I'll start this talk really a little bit also maybe from the perspective of where you are now as a student and maybe your near future as what will happen when you enter the world. And I'll take you a little bit through my journey as a young architect and how I started building my office and all of this other activities. So I graduated in 2008. Which is actually a moment very similar to maybe where some of you would graduate, which will be like 2020 or at least in the aftermath of the COVID-19 crisis. So 2008 was also a really kind of a bad moment in time to graduate. Until this year, I always said it's the worst moment ever to graduate as an architectural student. But I think we can top this up now with people graduating in the next few months or years. So 2008 was the moment that we had the great financial crisis, the global financial crisis, with a kind of a fallout that was really driven by speculation, specifically on real estate and things that we were involved in as architects. So that kind of generated a moment in time where there were the whole kind of construction industry really stopped and stalled, and all of the kind of projects in Dubai and China disappeared. And I was trained, or as a student, I was really, really interested in digital stuff. So I'm showing these 2 images, which I, in the meanwhile, 13 years ago, like these were the projects I was developing back in Belgium at architecture school as a kind of, I was a bit of a rebel as a student. So I was checking what was happening in London. I was checking what was happening in the United States, in schools like Columbia, at schools at the AA. I was reading all of these kind of theories by people like Berlin and Stijn, and I was getting ready, before 2008 to come into the world and build this kind of, crazy blobby buildings, as Klaas referred to them just before. And that briefly kind of worked because I was kind of lucky enough to, just while the crisis was hitting, some offices were still thinking that it was not hitting. So I got a job as a kind of one of the early parametric consultants with the very first version of Grasshopper. I was working for Lava in Stuttgart, building basically parametric models and experimenting with these very first instances of parametric softwares. But then the crisis really hit, so I had to move to Switzerland, which always escapes all kinds of forms of crisis. And I got a job at Christian Keretz, which was really an interesting moment for me because in many ways, Gerets was, it's a very different architectural culture than what I was interested in as a student and that I was working on in Germany. But I got actually really, really interested in the kind of discourse and the way of thinking about architecture that was behind that work. And I would say it's more like, you could call it a kind of a disciplinary discourse. It's also research-based. It's basically, they're basically working through thinking about the relationships between parts, the behavior of these parts within architectural buildings, and kind of trying to innovate somehow within those pre-existing assemblies. So I started to kind of really understand somehow a notion of architecture that is not that of a continuous blob, as we can see in these beautiful drawings by Greg Lynn. That's an architecture without parts, an architecture that kind of grows sorry, someone needs to mute his Berkay Özgen needs to mute his microphone.
A year later at James's wedding, Barney could not
to mute that.
Okay, cool. So I got interested really in an architecture that is the opposite of that, right? Like an architecture that is okay, like an architecture that is made of parts, that is about the investigation and the research of those parts. And then somehow, when after working in Switzerland, I managed to save some money to be able to continue my studies. So I invested that in going to the Architectural Association, to the Design Research Lab. I always really wanted to do that. Like I wanted to continue this kind of research that I developed as a student. But I went there with this background of having worked in Switzerland, right? And so this background was then confronted with this like absolutely crazy project, which was a proposal for a 3D printed house. Back in 2010, 2012, we worked on this. So it's a completely computer-generated, super high-res kind of fibrous mass of lines, of course, with a very different understanding of like what an architectural part would be or could be, right? So my idea then was really kind of to question when I started my own practice in 2013 to confront these multiple backgrounds, right? Because I think that's actually what makes a position interesting. If it's not homogeneous, but if you have this kind of, if you're kind of pulled by these two different kind of forces or interests, and that coincided as well with, in the meanwhile, what you would call kind of a fallout on that discourse of the digital. So after the financial crisis, there was basically a lot of criticism towards the kind of early digital, that they had not been kind of developed as a kind of social agenda, that there was not a lot of attention also to the kind of the politics of construction and how we could build. And at the same time, there were also a few really critical texts appearing by people like Mario Karpel, which were essentially arguing that the early digital, with their obsession of curvilinearity, and this kind of blobbiness, that they were actually not really digital per se, that they had actually kind of not fundamentally understood how computers work, and that the digital is not about curvature. And this is, I think, a super interesting debate. And I mean, a large part of my work is kind of founded on this debate, which is this debate really about whether architecture has parts and consists of parts, or whether architecture has no parts. And you could call this basically a debate of discrete versus continuous. Discrete meaning the individual parts, or continuous meaning that there is no parts. And this also kind of resonates. So the critique is basically, if you look into the definitions of a word such as analog or continuous, it basically means that there are no parts. So an analog signal in music or in computers, an analog signal would be a signal that cannot be brought back to individual discrete components. It's basically a continuous differentiation of the signal. Whereas a digital signal, of course, ultimately also always goes back to 0 or 1 or to the bit, right? So a digital signal is characterized by the fact that it consists out of little bits and pieces, which are generic, they're universal, And these bits are then compiled together into a signal that, if the resolution is high enough, may appear continuous, but that ultimately always consists of parts. So it turns out that actually the whole way that we as architects had thought about the digital up until 2012, 2013, is that we have thought about it in a continuous fashion. So we have thought about it that we would define an overarching form that has no parts, it's just one shape. And then we would use digital technologies such as robots or CNC machines or software to split this form afterwards into constructible elements. So the kind of construction, the act of building, and the parts come as an afterthought to the overall shape. And the kind of key example of that is Frank Gehry's fish in Barcelona. I don't know if you have ever visited this on the beach in Barcelona. It's the kind of one of the very first digitally constructed buildings that really takes the form of one part, which is the shape of a fish, and is then cut and sliced into pieces to be able to construct a fish. So this means that actually everything, and I was also kind of educated that way, is basically based on translating overall complex curvilinear form to a series of constructible parts. And these parts, they are not parts proper. They have no kind of meaning within that building, or architecturally they don't really have a meaning. They're basically kind of derived always from the whole. So if you look at one of those components independently, it doesn't really mean anything unless you know that it will help to construct this overall fish or whatever shape that we're looking at. So these parts are basically components, right? And they can also only be used always very specifically for the one position in that space. Now, if you look at how digital technologies are used in the world outside of architecture, they're very, very different, right? And they're actually used in a way that is much more related to parthoods and to questions of logistics, right? Like how can one part or one bit be traded, be communicated, be organized. So I always like this kind of image of the Amazon warehouse. Like that is actually digital production, right? Like digital production is a project somehow of kind of global logistics and of kind of interfaces between people and a certain set of discrete objects that are traded and moved around. So we also started to get interested in, going from this image of the Amazon warehouse. We also got interested in thinking about the digital, that it is not just a formal process, but that it's actually a process that has an enormous social and political repercussion on our world. Like the digital is reconfiguring almost anything that we know in our world, right? There are really big issues around things like privacy, but also the automation of labor. There's all kinds of political repercussions around the digital. And we thought that if we want to make sense of the digital as an architectural project, that we need to be able to discuss those political ramifications, and that we need to be able to argue about things like, well, if we do everything with robots, what happens to the jobs of these construction workers? Who owns those robots? What do we want to achieve with these robots, etc.? Like these questions are questions that are becoming increasingly important today. So the entry point, again, to kind of do that kind of work and be able to talk about all of those heterogeneous issues was really the kind of the confrontation between, on the one hand, on the right, this kind of completely generative and fully automated way of designing with, on the other hand, an idea about parthoods, right? About parts and about kind of their architectural meaning. And it's actually interesting. I mean, like now this seems pretty straightforward, but it actually makes a lot of sense to do that, right? Like architecture has this kind of like long-standing relationship somehow with the notion of the part. You can think about things like modularity, but you can also think about the building block. For example, Fröbel, the inventor of the kindergarten, invented this like timber building blocks that kids play with. And then, for example, Frank Lloyd Wright experimented with this kind of building blocks to design some of his buildings, right? So we were also, and I think that's important to mention, not the only ones working on this. You also have people like in Paris, people like Philippe Morel, who are experimenting with this kind of discrete building blocks as a way to look at architecture. Or people like Jose Sanchez, who are thinking, how these building blocks could interface with things like games and engage a form of participatory design, etc. So I came really in there, in that kind of debate, really with the idea to use these building blocks on the one hand as kind of a critical questioning of architecture and a kind of disciplinary culture of working with parts, and on the other hand, a kind of a real focus on automation and how we could completely change the way that we construct and build. And the interest is to set up a short production chain, so to be able to kind of, in a way, bypass the incredible complexity of construction and be able to radically simplify it. And I like to call it almost kind of reinventing the elementary particles or the elementary parts that architecture and building consists of. Because building is a process that is extremely slow, expensive, and wasteful. We don't know where our materials come from. There are hundreds and hundreds of actors working on this. And to put together thousands and thousands then of different pieces and processes results in building becoming extremely inaccessible, difficult to automate, and wasteful. So if you could just kind of forget about the way we construct today and just eradicate it and start again from scratch, questioning like, what is the material that we built with? What are the parts that we built with? We could actually make construction much more efficient and accessible to the many, while at the same time also using this as a creative project, right? A project that works on the imagination, that is also creative, and that wants to be beautiful. So that's kind of my research agenda, right? And we started working on that in the Bartlett. Initially, very abstractly, like we were programming robots to build this kind of beautiful, almost Baroque chairs from little repeating timber building elements. Then we started to scale this up. We were like, well, these parts, we need to make those parts bigger. Starting to program robots that would lift up those parts and begin to assemble structures from them. Always the same repeating parts. And again, at the same time, trying to speculate also about this kind of architectural meaning and the criticality behind this, right? Can we make this an architectural project? And there's obviously interesting historic references to this with people like Miguel Fisac, who, developed their own set of building parts in concrete and then designed series and series of buildings that were using his own parts, or also, the effort of modular construction in, on both sides of the Berlin Wall, where architects would kind of develop their own like building blocks, right? And so I really, really love these images, right? These images of the architect standing next to their construction system. Like they have just kind of reinvented construction from scratch, and they're like proudly standing, among the kind of building blocks, right? Or also people like Jean Prouvé there at the bottom. So that also turns out that we could really say that automation is a design project, right? You cannot see it as, we cannot just apply robots to construction as it is now. We need to first reinvent construction and design so that then it is primed to be used with robots. And for me, that's fantastic, because that means that we can think about robots, but at the same time, we can also be a little bit philosophers and theorists and fundamentally have these conversations about architecture itself, right? And just as a kind of a side note, for example, this is this very old conversation that was initiated by Colin Rowe, the architectural historian, in 1947, where he's basically comparing a Palladian villa with Le Corbusier's villas and arguing that, that these villas are actually exactly the same, and that they both consist of columns that are placed on a geometric grid. Just one is executed in white and the other one is not executed in white. But Rowe was basically saying, like, what happens to architecture if modernism did not actually manage to fundamentally change its syntax, right? We are still indebted to classicism, right? So you could say that with Bruno Latour, that we have never been modern, but at the same time, we have also never been digital. We still operate in this kind of framework, and a kind of analog framework to think about architecture. So the question that's driving my practice and research is then, like, if we have never been digital before, can we actually be digital now? Can we think about buildings that are put together in the same way that digital data works, with then all the kind of the radical consequences of that? Can buildings kind of consist only of data like parts, right, that are compiled rather than being kind of derived from overarching grids or overarching forms, where parts are always kind of derivatives. And I've kind of done that also. I mean, like these are kind of I call them my blunt architectural history classes. So I would argue that this model by Le Corbusier, that this is the most genius model ever in architecture. It's definitely the most successful ones. There's a very big chance that everyone who's in this lecture right now is sitting in one or another version of this construction method. It looks maybe different, but fundamentally this is kind of what the majority of the building stock in the world is built from these days. It's also interesting that this model was so genius that Le Corbusier, it took him probably 10 years to realize what he had done, right? Like initially when he developed this model, he didn't actually understand that it was this genius. It only came out later. So I would kind of argue that this model is extremely, extremely difficult to beat. It's really kind of it's really kind of resistant to any kind of changes, right? So in this kind of blunt architectural history diagram, I've kind of summarized everything that happened since the Second World War. So you have modernism, right, which is this model. And then you have postmodernism from the 1970s to the 1990s, which is trying to kind of, diffuse the universality of Le Corbusier's domino by adding elements to it. But fundamentally doesn't really change the model. It cannot really combat it. Then you have Peter Eisenman, his efforts, which is, I would argue, just making everything more complicated by having two dominoes that you rotate and shift the grid from. Then you have Greg Lynn and Zaha Hadid and Hani Rashid and the whole early digital, which is essentially, trying to hide the domino behind curved blobby surfaces to give the impression that we're in a different world, but it's actually made of plasterboards, right? And it's kind of not fundamentally changing that syntax. And then you have a recent kind of efforts, mainly in the United States. I think we have been saved from that, luckily, in Europe too much, which is an object-oriented ontology where basically people are kind of trying to shape these dominoes so that they look like little objects rather than floor plates, but then internally they're kind of still sliced. And then I would argue that the project that me and my colleagues are working on, the project of the discrete, that project is radically changing the syntax. So we're not interested in somehow its appearance or its style. We're not interested in trying to kind of camouflage this domino. Our interest is in eradicating that domino, right? With this kind of diagram, which is, a pretty blunt and a little bit ugly diagram, but I think it's great because it's kind of showing that where the battle is, right? So the battle is not in kind of saying like, oh, we're going to curve the slab in this domino, or we're going to make it appear differently. The battle is about basically the parthood relationships and in trying to just eradicate and build a building that has no columns and no floor slabs, that has no pre-existing typologies. And the journey there, I'll just kind of really go through that very, very quickly. The journey there happened by basically beginning to introduce increasing degrees of discreteness, so considering parts more and more and constraining parts more and more. So initially the work was still very generative and was kind of basically based on developing a series of projects that would introduce angular constraints in otherwise kind of continuous fields of data. Like this is a project in timber for the Guggenheim in Helsinki. It consists of thousands and thousands of little parts, and they're to a large degree discrete, so they're always repeating, but they still have a lot of different angles that they can connect with. So it would be fair to say that these parts are still to a certain degree derived from the whole and would still be rather complex to construct. But so back in the day, we were like enjoying basically the kind of high-res aspects of this work and kind of really looking at this kind of clouds of lines, right? This is another project we did for Budapest, one that actually we almost won this competition, and I was 27, just graduated from the Architecture Association. So the idea was to do a double stack of Mies van der Rohe's National Gallery and then resolve it into repeating kind of a cloud of lines that would kind of create this like fibrous tectonic. At the same time, always using very simple straight repeating lines, right? So you have this kind of in a way, floor slabs that are not anymore floor slabs, but that are just kind of clouds of lines that are assembled. And it dwells a bit on this kind of minimalist art, right? That it's not so much about somehow the form, but it's more about the organization of the parts. And I was also kind of, when I was doing this lecture, looking back at that period in time when I was working on this competition. And I think it's really great also to kind of think that as an architect, we could do this work. Like I was doing that kind of all by myself on a little laptop in between traveling to some places. Like this is at the airport, writing a script and processing to generate this structure, right? And I think it's fantastic that in a way as an architect compared to other disciplines that we don't actually need so much machines, right? The only thing you need is in a way an idea. And I think that's beautiful. Like you can just kind of, if you have a laptop and an idea, you can kind of sit down and begin to kind of create those visions and launch them into the world, right? So this is the brown envelope, which was then sent to Budapest. And then ultimately when, I was together with Shop, the New York architects in the selected for this competition, but then the jury decided to launch it again after they figured out that I was only 27 and doing this probably from a laptop sitting in the train or in the airport. So they were like, let's do a new competition only if you have won the Pritzker Prize before or the, another big award, then you can do this competition. Otherwise you cannot participate. Like this is not going to happen. So then Snøhetta and Sana together won the competition. But it's still kind of that project was very important for me. So I kind of kept working on other kind of visions of that project and trying to kind of think through what we had developed there, beginning to kind of construct and build it in different versions. And then a project that then came a little bit later was this project that's called BLOKHUT. In Dutch, that's like a log cabin, or like a kind of chalet in a way in French. The owner of my client, his surname was Blok, so that's also why it's called BLOKHUT. It's a house for Mr. Blok, and it was also made of blocks in itself. So the argument was that we would build this entire building just from 95% or 90% of these repeating elements, a little bit like Legos. The idea was that, the client was he knew that I would do something crazy. So I devised this kind of strategy to tell him like, look, I will do something crazy, but it consists of like 90% repeating parts. You only will have to pay something extra for, the 10%, for 10% of the building. But the majority of the building will be super, super rational, and it will just be an assembly of the same parts. So this is kind of the construction method. So what you see in the red zones are areas that are customized, but that I still have repeating connections. And then the white ones are just kind of, the same parts repeating all over again, right? So these repeating parts are kind of joined on these ribs. We made a huge model to kind of demonstrate that we could build this, that we could build this structure. And then I think architecturally what came out of this really kind of then started to define my practice, right? Because I think this is a very strange kind of model of architecture. So on the one hand, it's serialized, it's repeating, it's highly rational. On the other hand, it has something natural, something eroded, something tactile. And it's on the one hand also familiar. It has the kind of the two slabs that we recognize, that is very banal and that we see all around us. But on the other hand, it then also tricks, that does like a kind of a trick with the slabs, which make that the slab actually doesn't really exist, but it's just an assembly of parts. So I thought architecturally, I was really excited by this kind of spaces and this kind of outcome, because it, on the one hand, it's very efficient, but on the other hand, it's also, I think, very imaginative and able to do things that we're not really used to. So on the left, that's the model. On the right, the rendering, right? And that's then the kind of the image of this building sitting in its garden in a kind of forested area. And I thought that was like great, right? That we could somehow develop that kind of vision that is about assembly and about modularity, but it's not anymore this kind of 1950s, 1960s boring, repetitive form of modularity, right? We're now able to do a project that capitalizes on modularity and on its efficiencies, but that can result in buildings that are, that are complex, that are inspiring, and that offer something different in every instance. Anyway, the client obviously didn't want to go with his image, so ultimately he built this building on the site in Belgium. It's also very expensive. Like it's really not a cheap building. It comes in around like 700,000 euros. So no further comments. So anyway, the good thing then also, if you work, as an architect in this kind of system, that you develop your own construction system in a way before you have a commission, that also means that you can recycle your designs and your construction systems in many different projects. Like you don't need to come up with a new construction system every Monday, right? Just as Frisac was doing. So I recycled that kind of same building element into a number of other competitions or pieces of furniture to further developments. But then I actually had a chance to, further question kind of the project that was set out by the BLOKHUT. I won a competition in Estonia, in Tallinn, for the Architecture Biennale, to build a pavilion there. And the idea was to not build a pavilion, and they asked for a pavilion, but I wanted to build a kind of a Maison Domino-like abstract structure that would, in a way, communicate ideas about larger scale ways that we could build, right? So I was looking at large-scale timber housing blocks, and the idea was to first design a kind of a housing block myself. Like, this is the housing block, and then extract kind of a part of that housing block and build that as a pavilion, arguing for a new way of constructing architecture that will be based only on repeating sets of parts that are made of a single material and that only use a single machine. So just a CNC machine, stacks of plywood, you assemble these parts into building elements, and then you can construct that installation. But you could also take this installation apart and assemble it again as a piece of infrastructure like a bridge or another structure. So that kind of shows this radical potential of a discrete form of architecture where if parts are independent of the whole, you could use them to construct many different types of buildings, and it could also result in a kind of a circular economy where these parts could be recycled. And not only the part is modular, but also the construction workflow is modular. So we start from a single sheet of timber, and every sheet can be cut into subcomponents. The subcomponents then get assembled into a structural part that has to be able to perform in every instance of what we are going to build. And these parts are brought together with reversible connections. So we're using steel rods to push these parts together under tension, using this kind of Lego-like connection. So you can begin to kind of create larger features with these parts, but you can always still take them apart, right? And you can also only obviously connect them there where a connection has been defined. And then in the end, we kind of hide all of the engineering aesthetics that are inside of these parts, and just like these parts are kind of abstract, almost artificial pieces of timber that don't reveal their kind of inner logics. So to build this project, we rented, this was all done on a very small budget. We rented a former slaughterhouse in Tallinn in an old factory. I called up a bunch of friends and I found these two German traveling timber workers. They are called Wandergesellen. I found them on the streets. They were looking for a job in return for beer and food. So I was like, that's perfect. You guys are going to join me and you will kind of help me build this timber project. So these guys stayed with me in the factory. They were actually living in the factory, like they were sleeping here on cardboard mattresses. And then in the morning, they would wake up as proper Germans, begin a hard day of work, and then drink a lot of beer going into the night. So we set up this little modular factory, right? Kind of creating this kind of stock of elements, and then ultimately kind of wrapping this up in 4 days. That's the small team that constructed this. Then we put everything on a truck, drove it to the site, and started kind of constructing this project again in a very short time. So we were only 4 people and 5 days with very unlucky weather circumstances. So this was my mobile office during the construction of the pavilion. And you see this kind of incredible, I mean, it's an incredible way of building, right? So you kind of have this large, almost Lego-like parts, and then you just kind of, they're always the same, right? So you can just lift up a part, you position it into place, you connect it with the steel rods, and slowly you kind of build up the features of that structure. So I think I always like to kind of look at the scale of this thing. Right? Kind of, it's a little bit larger than the human body, so it's a super strange kind of way of constructing this. Then you have these kind of crazy corners. And this is all done with plywood, right? Like this is a shitty material, super cheap. The only thing we add to it is an idea and some algorithms, and then you can kind of basically do something insane with this like simple base materials. Right? That's the opening. And then I think it's great like to kind of look at this pavilion and kind of the different, it's very different from every angle. And it does, again, a kind of an architecture that proposes something extremely different for modularity and assembly, right? It has kind of strange, it looks like partly eroded. It has these strange slips in topology. It does this kind of like very strange features. And at the same time, again, it picks up on lots of elements also from the previous project. Like it's slightly familiar. You see this kind of two horizontal lines, which seem to insinuate that this could construct something that can be stacked and repeated. But at the same time, there are no familiar elements in the structure. And then these are some housing blocks that then, that go along with this pavilion, where you can argue that you could construct, an apartment building that is not limited to kind of 1, 2, 3 bedroom apartments, but technically this is just made of always the same repeating part, and this part could be positioned differently in every instance throughout the building at no extra cost, right? Like to make the building different, you don't need to customize parts, you just position parts differently, which is a very, very different idea about creating difference, right? Because it comes at no cost. Like the only cost is an informational cost, which we know in times of the digital is for free, right? You can just basically tell someone, well, you don't put it there, you actually put it there without changing the parts. So that generates this kind of like a building that breaks all kinds of conventions of that. And then I think it's interesting when we compare the project I showed you before, the one that unfortunately kind of failed, that we didn't manage to build, and this one. And I would kind of argue that they're in fact very similar, right? Like they kind of work out similar features. And in a way, by building the pavilion, we kind of demonstrate that the vision that was set out on this project, that is a feasible kind of notion. And now we're currently working with a bunch of Romanian minimal techno DJs who are a big fan of this project, and they want to build it in a forest in Romania. They want to build a small recording studio and kind of club in a way to host like minimal techno festivals. So they've set up an amazing kind of open source project, and we're going to be kind of supplying them with the building as part of this effort. So anyway, at a later stage, I kind of continued these ideas in other projects. Like this is a multifamily residence also in Belgium, 3 apartments, built always of a repeating L-shaped element on 3 different scales. And I think this is one of the kind of, for me, one of the best examples of what a discrete architecture could look like. The fact that there is no overarching form. The building is like perpetually in a way unfinished, or could continue. It could also be disassembled and take another form on another site. And also the way how it subverts everything that we know about architectural construction, right? Like it has no floor slabs, yet it has the familiar kind of, the kind of familiar horizontal lines. It looks like it's very heavy, but actually it's very light. All these building blocks are actually hollow. They're not solid. And it looks like it's very complex, but actually it only consists of the same repeating parts. It's actually highly rational. And then architecturally, I think it's also interesting because it's on the inside, it kind of gives us an architecture that is almost organic. Like this is almost kind of the experience of being in a cave or in a kind of a natural environment where the same material defines everything, right? So all of you're in a system where exactly the same parts kind of define everything around you. And then the building itself there's some drawings of plan drawings where it leaves a lot up to interpretation of the inhabitants. Like, it doesn't want to prescribe a kind of a mode of living there, but I compare it always a bit to camping, right? It's almost like you arrive in this kind of space and then you need to kind of begin like almost camping, kind of set out the way that you want to inhabit these spaces. And then again, we got a chance to build this. And I think that's just kind of important in this lecture to show how we go from very kind of speculative and visionary projects to then proving that we can build this, right? So this is a project for the Royal Academy in London, where I got commissioned to build an installation. So we, again, set up a little factory, prefabricated lots and lots of these building blocks. And here you see, this is Ahmed, one of my collaborators, and you see kind of the relationship between the mass of the element and the weight, right? It's actually very lightweight. And, we prepare these stacks, we move it to the Royal Academy, we kind of have an impromptu exhibition in the exhibition spaces, and then begin to build that structure, right? And again, it's kind of a very quick building process where we just add this kind of massive, Lego-like modular parts together. And ultimately it results in this kind of a section of the building, which is, in a way, it's kind of a part of the project I showed before, right? To kind of show that we can build this on like tiny budgets, and that is kind of, it kind of makes people dream, including myself, about that it could be possible to construct these things, right, in a radically different way. You see also that Johan here in these pictures is wearing HoloLens glasses. So we were actually kind of using the HoloLens to communicate the digital model to what we were building, right? So it was always giving us an indication where we had to place the next part, and then we could easily kind of construct this entire thing. These are the kind of ceilings. And then chunks of this building were spread throughout the Royal Academy. This is the opening where we had Mario Carpo and Peter Cook. And the whole installation disappeared actually on their visitors, who were all kind of sitting on this thing and then debating the consequences. And we keep developing this. So in the meanwhile, I think we're at iteration 5 of these building blocks. So we keep scaling them up in different contexts. Like this is in Shanghai last year during Digital Futures, where we constructed this kind of really, really big blocks. Yeah, like that's one of the Chinese workers. This is a block. And recently in Belgium, we built, I think, the largest one. This is Kevin. He's not a small guy. Like he's almost 1.90 meters, and then this kind of massive building block next to it. And now we're applying this this summer. We're actually going on site in Ghent. We're building this extension for a house, very small project. It's just 6 by 6 meters, but it's going to be built with these parts that we tested in this workshop before. So it's kind of like this is again like kind of an important moment to show that we can build this thing, right? And the interesting thing is, so this is just one project, but because the parts are always modular and repeating, we will then also launch this as an automated building system that potentially, all the friends from this client could also kind of apply the same system to their house extensions or even self-standing buildings, right? And again, it's kind of, showing how from this vision of that project, 2 feet on the ground, trying it on a small scale, and then hopefully at some point scaling it back to that vision, right? This is all the kind of engineering that goes behind this. We're doing this with Manja van der Warp, who had engineered also our Tallinn and Royal Academy installations. And so she's basically working now on, in a very detailed way, trying to understand how the structure works, right? And of course, like what I'm showing you now is kind of hands-on work with my practice, but I want to also show you a little bit speculation of like what our vision is on the larger scale, where we would actually begin to build these things with robots, right? So I'll quickly flip through some of our research projects and student projects that we're doing in the Bartlett. Like this one is, I think, very interesting. This is It's called Assembler by Avotetbury. And the idea is basically to have a kind of a repeating timber building block, which can be assembled by robots, but it also has a custom designed distributed robot, a discrete robot, you could say, which is kind of able to assemble all of these building blocks on site. So the argument is basically you arrive with a truck with all of your modular parts, then you have a piling robot that puts the foundations, and then you have these little climbing robots that always grab a modular part and assemble it into a larger structure, right? Which then could result in this kind of this little hut that you see here. But also it has a lot of implications for infrastructure, like in difficult terrains and developing countries or in areas that are very difficult to access. We could, build things like bridges, for example. Like this is kind of a little speculation on how you could build a kind of a bridge structure across, like with these robots cross a kind of a natural environment. And here, I don't know. I'll just switch on music. This project is a kind of further speculation on this. It's called Pizza Box. It starts with the idea if a robot could be, as simple as a pizza box. So it's just a square box. The orange one is a robot. The white one is a building block. So it's not a robot. The robot and the building block are exactly the same. We're speculating about how this discrete robot could basically assemble parts together. Also, how these robots could collaborate with each other in building structures. Then this is in the corridors of the Bartlett, where this robot is kind of like walking around, and we're kind of demonstrating on a small scale how these things could work and how we could assemble bits and pieces with this. And then we're testing this then on a larger scale with industrial robots. So just to show, we don't have the in-house capabilities to develop that robot on a bigger scale, but we can use the industrial robots to speculate about kind of simulating the movements of these building blocks on a one-to-one scale to show, to kind of explore the difficulties and show how this construction process would take place, right? You can see that there. And then we also do weird things where we're, for example, using machine learning and AI processes to train these robots. You should check the third one here. The third one is in trouble, going over that little hill. So we're basically, using machine learning to train these robots to figure out their assembly sequences, then developing an almost like BIM-like software where you see hundreds of these robots at the same time creating a larger structure, right? And again, it's super interesting to consider that this is modular, right? This is a modular assembly of parts, but it results in a kind of a fully automated way of building that is complex, that is adaptive, that is circular, and that is in one way or another also kind of organic, right? This is kind of some visions of that assembly process on site where you see all of these little robots. That could be construction, right? You see all of these little robots kind of going from their container and assembling this building. They're quite cute, I think. I like how they kind of move. That's the kitchen there. That's an actual pizza that is in the building. And then the kind of, the kind of vision of how that automated architecture could look like. Yeah. And lately then, we're also obviously always then exploring these things on a scale 1-to-1. Also applying this on other materials. This is very low tech. This is just working with bamboo, and we're using machine learning to check the length of bamboo and identify the joints, and then give you instructions with a HoloLens how to assemble bamboo. Super, super simple, no robot needed. And then that's the kind of bamboo building that results from that. And now lately we're working a lot on actual housing blocks. Also, to kind of really trying to compete, showing how we can do modular constructions in timber in more exciting ways that are not kind of, so limiting, right? But that remain efficient in the construction process. And I just wanted to also show this one here. That's a really cool robot that our students developed. It's inspired by TARS. And it's a very kind of simple robot. It moves CLT boxes around, and then the construction workers just basically drill the boxes together. And I'll quickly show you, I think I have a little video here. Quickly show you some of some ideas of these robots. So the robot in itself is also modular. It actually consists of a single axis. I'll skip a little bit through this. Yeah, so this is the robot. So it's just a single axis actuator, and you can combine these axes together to create different body plans for robots. So, and then other robots could assemble one robot, right? So you can build, it's kind of a universal construction system, right? Where a robot can build another robot, and they can construct this kind of ecology, basically, of construction machines that their body plan could then evolve in relation to the task that they have to do. So our students here are, building very, very simple, blunt versions of these robots. And again, like the students, they are people like you and I, right? They are not engineers. They are just architecture students. I think very important to mention. They come to the Bartlett also not knowing anything, like not being able to code or build robots. But we kind of work, during 1 year on developing these processes and get our hands on it and beginning to kind of understand how we can, speculate about construction machines, right? And then also playing games on a larger scale, playing games with the industrial robots, having him also assemble and simulate sequences of these parts, and then using machine learning to train these robots virtually. Like this is a little race that we're doing between these robots, where we're trying to kind of program their behaviors. And then you see what building could be, right? It's almost like 3D printing. So this is really just kind of, a mobile axis that is stacking sheets of CLT material together. And building becomes very different. It's just a single part. It's almost like 3D printing, not 3D printing with plastic, but 3D printing with CLT blocks, right? See these robots kind of, walking and yeah. And then we built some, the idea is then that also we could build some like really strange buildings, like for example, buildings that are extremely long or, et cetera, et cetera. And then recently, we're also now doing projects like this is one that I just did as a visiting professor in Hong Kong, at Hong Kong University, where we are also looking at kind of integrating more of these robotic and kinetic aspects in real time to empower users. So this is basically an apartment block that is made of a lot of discrete pieces, but some of these discrete pieces can actually rotate. You can actually open them with an app so that you could decide to share or not share a space. So this is an individual apartment, but then you could negotiate with your neighbors that you want to rotate some walls, some of these robotic walls, and then you could temporarily create a co-working space between two apartments, or a kind of a dinner setting or something. So that also completely changes then economic aspects of like, space-time economy, how you use spaces, can we double use spaces, et cetera, et cetera. So you can see that here, that's like the open version where the robotic wall is open and then here it's closed, right? So you could do that with an app, and then you could say like, well, I'm closing my wall now, I have ulterior privacy. But during the day, maybe your apartment is a gallery and this wall is open, right? And you can manage that through an app. So, and these are some physical experiments with the students where they make this kind of CNC plywood boxes that are then connected with these post-tension rods, and then the kind of robotic door there in the middle. And so I'll probably wrap it up here. So now with the last bit is in a way with with my design tech consultancy, with my startup. We are trying to bring these technologies from academia to the world. And this is very different from my architectural practice because, my architectural practice is a traditional architectural practice. I'm doing competitions, I'm waiting for commissions. And of course, it's a bit experimental, but it's not fundamentally changing the model of the architect itself. Whereas this is really a tech company. Like this is a company that employs architects, like we're a team of almost 10 people now, but we are working with consultancy models and we are working much more with a kind of a tech startup model. So we're not doing architecture competitions. We're not waiting for clients, but we're developing technologies. We're consulting with big companies and governments. And we're working on our own building system that at some point we want to launch as an actual startup. So this is our temporary office that we built in London. This is also made of like super simple timber boxes. You'll see this in a bit how we constructed this. And so we're currently working with like a bunch of like really cool collaborators, like Epic Games, people from Fortnite. We have some grant funding from the UK government to develop some of these construction systems. And we're mainly working on 3D printing and robotic assembly as technologies, and then all kinds of other things that come from that. So it really started like a few years ago with us 3D printing this chair and developing the software for that chair. And then kind of scaling that up, right? And it also, like the other book that I mentioned before, Robotic Building, is part of our efforts with automated architecture. So that as well, we're producing theories. Also, we did the proposal for the British Pavilion for Venice. We almost won it. Really, really sad. We got very close to doing that. That was a fully automated pavilion. So the idea was that there was not going to be a curator, but that it would only be kind of an AI that would curate content and work with people online to send Amazon packages to the pavilion. And then robots would kind of organize those in a warehouse, like kind of funny and a little bit cynical maybe. But the main thing that we're working on is this project that we call Robot Built Housing. So we're really kind of trying to, with grant funding and industry partners, to develop a completely fully automated system for construction that is based on this modular timber building blocks. So, for example, with Epic Games, we're developing an AR kit that we can control industrial robots in a very simple way, that we can program them through AR to assemble parts. We're developing also the kind of the processes of how we can construct those parts themselves in a fully automated way. And then the kind of whole BIM software of like instructions of how these parts can be assembled together. And we're building this thing in September. We're building this in Hackney. So Hackney is a community in London, and they're very interested in new housing models. So as a demonstrator, we're building a kind of a transformable live workspace to show how we could build radical new models of housing. So we're building this one on site, and we're going to be hosting some kind of parties and lectures and talks in that thing. And of course, with then the speculation in mind that, you know, that same building system could scale up and construct, actually become this kind of modular construction system that is fully automated, but could result in extremely different ways of building it. So yeah, I'll keep it here. I mean, I'm only halfway through my lecture, but I don't want to bore you guys too much. So we're just going to like flip through this maybe so you see a little bit what else you are missing. And you can look this up when you Google me. You can find other lectures, and then you can check out my work, and you can learn a bit more about these other projects that we're doing. And I think you can also, I was going to say, like, you can also obviously follow me on Instagram to learn more about the work, check out the website, buy the books. And also I want to do this little promo that you're very welcome still to apply to the B Pro at the Bartlett. We are still accepting, there's a few spots left for the program, so you're still very welcome. Check out the work. If it's not this year, maybe in a few years, we can welcome you, and you can join this research agenda and contribute your bit in changing the world. So I'll stop it there. Thank you so much.